Assume that a drop of liquid evaporates by decrease in its surface energy so that its temperature remains unchanged. What should be the minimum radius of the drop for this to be possible? The surface tension is T, density of liquid is rho, and L is its latent heat of vaporization. Now in this case, if we consider a drop of radius r and its surface tension is T, then surface energy given by 4 pi r square into T. This is surface area, surface tension. And energy required to evaporate this U2, that is equal to m into L, that is equal to 4 by 3 pi r cube. Density of liquid drop is rho and L is latent heat of vaporization. Now according to given problem, du1 by dt should be equal to du2 by dt, because this heat is used for vaporization. So this comes out to be 4 pi T is a constant, R is variable, so this comes out to be 2R into dr by dt, and this is equal to, in this case also, 4 by 3 pi rho L is a constant, and this comes out to be 3R square dr by dt. So you can see, we solve this, 4 pi and 4 pi will cancel out, dr by dt, 3 and d will cancel, r and r square, 1r will remain. So 2t equal to rho L into r. From this we get r equal to 2t by rho L. 2t by rho L. So answer is 3. Third answer is correct. Okay, in this problem, graph between angle of deviation and angle of incidence I for a triangular prism is represented by, we will have to find out which graph is correct. We all know that if we consider a prism, triangular prism, and if a ray is incident at angle of incidence I and comes out at an angle E, if A is angle of prism, then deviation delta is given by I plus E minus A. Now we know that as angle I is increased, first deviation decreases, becomes minimum for some angle of incidence, and then again it increases. This is a standard graph. All of you must be knowing this. So here, as I is increased, delta first decreases, becomes minimum for some angle of incidence, and then it again increases. So this is a standard graph, all of you must be knowing. Answer 2 correct. Okay, in this problem, let epsilon naught denote the dimensional formula of the permittivity of vacuum. Capital M equal to mass, capital L equal to length, capital T equal to time, and capital A equal to electric current. Then we'll have to find the correct option. We know this formula F, that is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This force of interaction between 2 point charges known as Coulomb's law. From this, epsilon naught depends on Q1, Q2, F and R square. If we see the dimensions, then dimension of Q, IT, again Q, IT, F, dimension of F, MLT minus 2, and R square is L2. On solving this, we get epsilon naught dimensions M minus 1, L minus 3, I 2, T 4. So M minus 1, L minus 3, I 2, I is A, here this is written A, M minus 1, L minus 3, A 2, T 4. Answer is first answer is correct. In this problem, the above PV diagram represents the thermodynamic cycle of an engine operating with an ideal monatomic gas. The amount of heat extracted from the source in a single cycle. Heat extracted from the source basically is heat given to the system, heat given to this cycle. So in this case, these are two processes, this process and this process, where heat is extracted from the source. So in this cycle, we'll have to calculate Q1 for this process and Q2 for this process, and answer will come out to be Q1 plus Q2. Only during these two processes, temperature increases. So only in these two processes, heat is extracted from the source. Now to calculate Q1, you can see that this process is taking place at constant volume. So this is isochoric process. We can write Q1 equal to N CV delta T. CV for monatomic gas is 3R by 2. So this comes out to be N into 3R by 2 into delta T is 2 P naught V naught upon NR final temperature minus P naught V naught by NR initial temperature. On solving, we get Q1 equal to, you can see NR is NR, will cancel out. 2 P naught V naught minus P naught V naught is P naught V naught. So this is 3 by 2 P naught V naught. Q1 comes out to be 3 by 2 P naught V naught. Now Q2, this process is taking place at constant pressure. So heat involved is N Tp delta T, which comes out to be N 5R by 2. Now delta T final temperature is 4 P naught V naught upon NR minus this 2 P naught V naught by NR. Comes out to be 4 P naught V naught by NR minus 2 P naught V naught by NR. 2 P naught 10 P naught V naught by 2. If we add Q1 and Q2, Q equal to Q1 plus Q2, this comes out to be 13 by 2 P naught V naught. And correct answer is first. Okay, in this problem, sonometer wire of length 1.5 meter is made of steel. The tension in it produces an elastic strain of 1%. What is the fundamental frequency of steel if density and elasticity of steel are 7.7 into 10 to the power 3 kilogram per meter cube and 2.2 into 10 to the power 11 Newton per meter square respectively. So in this case, density and elasticity, density is given equal to 7.7 into 10 to the power 3 and elasticity, you can say Young modulus, given by 2.2 into 10 to the power 11 Newton per meter square, and this is kilogram per meter cube. Also this is given that strain, that is delta L by L, is 1%, or you can say 10 to the power minus 2. We all know that Young modulus Y is equal to T divided by A delta L by L, where T is tension in the string, A is area of cross section of this wire, and Y is Young modulus. So this comes out to be T equal to Y A delta L by L 10 to the power minus 2. The fundamental frequency for this wire is given by 1 by 2L under root T by mu, which is equal to 1 by 2L under root T upon A into D. The value of T by A from this expression is given by Y into 10 to the power minus 2. So F is equal to 1 by 2. L is 1.5 meter into 1.5 under root T by A. From this expression, the value of T by A is Y into 10 to the power minus 2. Y is given 2.2 into 10 to the power 11 divided by into 10 to the power minus 2 divided by D, that is given 7.7 into 10 to the power 3. On solving this expression, we get fundamental frequency equal to 178.2 Hz, which is answer 1. Okay, in this problem, two statements are given. This question has statement 1 and statement 2. Of the 4 choices given after the statements, choose the one that best describes the two statements. Statement 1 says that higher the range, greater is the resistance of ammeter. And statement 2 says that to increase the range of ammeter, additional shunt needs to be used across it. We know that if a galvanometer converted into ammeter, then a wire of very small resistance called shunt is connected in parallel with the galvanometer. And if range of this galvanometer is I, then shunt required is Ig into G upon I minus Ig. According to this formula, this is evident that statement 1 is wrong and statement 2 is right. So, given 4 choices, statement 1 is false, statement 2 is true, answer is C. Okay, in this problem, what is the minimum energy required to launch a satellite of mass m from the surface of a planet of mass capital M and radius r in a circular orbit at an altitude of 2r? So in this problem, initially this satellite is at rest on the surface of this planet. So total energy, initial total energy is only potential energy, that is given by minus gmm by r, where capital M is mass of planet, r is radius, and small m is mass of particle or this satellite. Now we want to launch this circular orbit at an altitude of 2r. So at an altitude of 2r, its height is 2r, so radius is 2r plus r, that is 3r. Now in this case, this particle will be having both potential as well as kinetic energy. So total energy final, we all know this is minus gmm upon 2 into r, where this particle is orbiting in radius r. R is 3r, so this comes out to be minus gmm by 6r, and the difference of these two from the equation 1 and equation 2, if we take the difference T final minus T initial, so this comes out to be 5 by 6 gmm by r, which is answer 4. So in this, answer 4 is correct. Okay, in this problem, a projectile is given an initial velocity I plus 2j meter per second, where I is along the ground and j is along the vertical. If g equal to 10 meter per second square, the equation of trajectory. We know that equation of trajectory is given by y is equal to x tan theta minus half gx square divided by u square cos square theta. Now here velocity u equal to I plus 2j, so its magnitude u is root 5. Tan theta is equal to y component by x component, so 2 by 1, that is equal to 2, and cos theta is equal to 1 by root 5. Putting these values, y is equal to x tan theta, so 2x minus tan x square by 2 into 5 into 1 by 5. So on solving this, we get y is equal to 2x minus 5x square. So answer 1 is correct.